So the main problem with the function sine, x sine 1 divided by x, is that we have division by 0 that we're not sure how to handle. If we go ahead and graph this function, you can see some craziness going on here. So the idea of the squeeze theorem is if I have this crazy function here, I might not know how to find the limit based on what's going on in this oscillation that we're seeing. However, if I can find two functions that can be above and below the current function, then I can use those two functions to help me identify the limit. So what do I mean? So we can keep zooming in here and seeing some shapes going on. So if I write the absolute value of x, right now I can see all these values touching the lines of the absolute value. So this function, this purple function, is always above the function that we care about, our green function here. And if I do the absolute value of the negative absolute value of the reflection, I can also see that, and even when I zoom out, I can see that it all meets inside that function. So if I can work with the absolute, these two functions, the absolute value above, the negative absolute value, and identify the limits, and we'll talk about that, how that works algebraically in a moment, then that can help me identify what's going on right here as I get closer and closer and closer to 0. Keep seeing, keep zooming in. That's crazy. So that's that one. Let's now talk about the other function that we have. This one is x squared. Actually, let's reset this. X squared cosine of 1 divided by x. So again, the problem there that we have is this 0, 1 over 0 being a problem. So looking at this function this time, a lot more weirdness going on here. So I'm finding that it's kind of hard to see. So what I'm going to do is go up to the wrench, I guess, and I'm going to go ahead and try and change this y-axis, because when I'm zooming in, it's zooming in the same for both, whereas I want to try and change what's happening with the y's. So I'm going to go ahead and add another 0 to both of these and see if I can see. Now I can see a better picture. Let's do one more. And here now I can actually see a really clear shape of the function, the quadratic function x squared, how it matches up really beautifully here. And then with negative x squared and how that matches up there. And we're going to use the fact that the red function is in between these two, the blue and the green function, to help us evaluate the limits. And we'll do that algebraically, but this is seeing it graphically.